The 2030 United Nations SDGs are the main framework to assess progress in global development and health. Governments, assisted by international organizations, will need to achieve these ambitious SDGs. However, how do governments know what is working and what is not? How do we track progress on achieving these global goals? In the absence of good cause-specific mortality data in most low-income countries, there has been a push to monitor progress through econometric modeling. What is econometric modeling? It's an indirect way of estimating an event, let's say the percentage of deaths that occur from malaria in a population over time, but the method relies not on direct measurement of malaria deaths, but on indirect relationships with known other variables. So, for example, the overall levels of mortality or levels of poverty, or even factors like rainfall. These variables are used to predict the distribution of the major causes of death, in this case malaria. The most widely cited global model in mortality is called the Global Burden of Disease, or GBD, which began in 1993, led by Dean Jameson when he was leading a World Bank report. The basic idea that Dean came up with at that time was to combine mortality and disability estimates in order to help countries establish priorities. This measure is called a Disability Adjusted Life Year, or DALY. How do you make a DALY? Let's think of this like baking a cake. The first ingredient is the total numbers of deaths and births in a population, which usually has come from the United Nations Population Division. The second, and probably the most important ingredient, are good cause of death data. This is the most important ingredient because these are the data with the largest gaps. The GBD uses cause of death data from various sources, such as police records of violent crime, and extrapolates the cause of death data from one country, like Mexico, to another, like Tanzania. The third ingredient is some measure of disability, mostly taken from expert opinion. And the fourth ingredient is to examine some key risk factors, which mostly are derived from the public health literature, and these risk factors are then applied to these death and disability totals. So, you take these ingredients and you put them together in this econometric model. Think of this like the oven, which then leads to the DALY estimate. GBD is obviously useful to ensure that global totals of diseases are consistent and helps provide a global overview of the major trends. How valid are the results at the country level? This is a little more complicated because the modeling assumptions for each of the 4 ingredients can be problematic. Let's consider the case of China. The GBD stopped using the UN birth totals and started using their own. As a result, the GBD estimated that in 2016, China had 11.3 million births, whereas the UN estimates were 16.8 million births in that same year. That's quite a large difference of 5.5 million babies born. So who's right? The best standard here, again, is the direct data, which in China's case would be the 2010 census, which estimated about 16 million births. Moreover, China has relaxed over the last few years its one-child policy, and reported births are increasing. So it appears that the GBD underestimated total births in China, and it would follow that the total numbers of child deaths will also be too low. A similar scenario arose in South Africa, where the GBD models suggested that over the last decade or so, child mortality rates per 1,000 live births were increasing by 3% a year. The local census officials and statistical departments replied that no, the child mortality rates per 1,000 live births were decreasing by 3% a year. Risk factors are another area where direct data have an advantage. An example of the difficulties of ranking causal risk factors is shown in the marked differences between the risk factor rankings of DALYs in India for 2010 and for 2015. Smoking was third ranked in 2010, but fell to seventh rank in 2015. And you also see quite marked changes in some of the variables. These differences do not reflect necessarily the change in risk factors, but they reveal a change in the modeling methods. So we can conclude with 2 points. First, the current GBD mortality totals are probably very useful at a global level, but the country-based estimates and the burden of causal risk factors is more difficult to assess, particularly because it relies mostly on econometric modeling. The second conclusion, and most important, is that reliable direct data are essential at the national level. Direct data not only give each country a clear roadmap to meet the SDGs, but importantly, direct data can improve the global modeled estimates as well.